This is review 2.6. So this is the review for our second quiz on exponential models. So again, it's just the content that we've seen in 2.4 and 2.5. So there were two new lessons, 2.4, 2.5. This is the review 2.6 on that material. So there are three formulas that we worked with in this section. You will see them just like this with no explanation. And you will need to know when you look at this that this is exponential growth. The next one you see is exponential decay. And the next one you see is half-life, which is just a special case of exponential decay. Okay? So then I ask a few questions here. Number one, consider this exponential model. What is the initial value? You will always get the initial value just by copying down the number that you see there. And you look at this model, is it growth or decay? To figure that out, you look at the number inside the parentheses. Numbers less than 1, we're talking about decay. So in this case, this is exponential decay. The growth or decay rate, okay? It's easier to figure out the growth or decay factor, okay? Because that's just copying down the number inside the parentheses, okay? 0.87, that is the decay factor. To find the decay rate, I need to put it in the form of the equation. So the form of the equation was y equal a 1 minus r to the x, sorry. So that 0.87 needs to be written in the form 1 minus r. So if you figure out 1 minus 0.87, that is 0.13, okay? So I can write this as, this model can be written as 2600, 1 minus 0.13 to the t, okay? So that means that the decay rate, always percent, is 13%, okay? So it's a 13% decay rate. If I look at the next one, I have an exponential model. What is the initial value? Again, please don't miss this. It's just as hard as copying down the number you see in front of the parentheses. Is this growth or decay? This is growth because the number I see inside the parentheses is greater than 1. So it has a growth factor. So the growth factor is 1.072. To figure out the growth rate, this is 2,000, 1 plus 0.072 to the t. So when I look at that 0.072, that's where I'm getting my growth rate. Convert it to percent, and that is 7.2%. Then we have some word problems where I will describe growth or decay, and you have to give a model, and very important, you have to represent what the variables are in the model. So in this case, the population of coyotes in College Park has been studied since 2010. At that time, the population was 87 coyotes. If the population is growing by 6.1% per year, write an exponential model, P of t, that models the populations of coyotes per year. So they told me to write an exponential model, P of t. Okay, what am I looking for? This is growth, so I've got to figure out something that looks like the formula that we have here. So it's a 1 plus r to the x, something like that. So a 1 plus r to the x, but my x happens to be t for time here. So what is the initial value? The initial value was 87 coyotes. Is this growth or decay? It is growth. It is growth by 6.1% per year. So that's 0.061 and then t. Okay, that's my model that represents growth. Now what does P represent? P is the population of the coyotes. What does T represent? So T represents time, but be more specific. It's the time since, when did this model start? That was in the year 2010. Okay. In this model, what does the model estimate the population to be in the year 2025? Okay, so in the year 2025, so 2025 minus 2010 is 15. So I just need to figure out when t is equal to 15, what does my model give me? So it's always helpful, write down what you have, 1.061 to the 15. That way if you make a mistake on your calculator, I know that you had the right idea in mind. So I just need to figure out 87, 1.061 to the 15. So 87 times 1.061 raised to the 15th power is 211, 471. So 211, 471. So that is about 211 coyotes in the year 2025. In what year? That is solving for time. That just got a lot easier on this quiz by not having to use logarithms. In what year will the population reach 120 coyotes? So I'm looking at equation 120 equal 87, 1.061 to the t. And I need to solve that for t. So on my calculator, I'm going to use the nsolve command, which is menu 31. So menu 31. And I'm trying to solve when does the population equal 120. So 120 equal 87 times 1.061. Let me make sure I got that right. Yeah, 1.061 raised to the t power, and bring the cursor down, comma, t. That means solve this equation for t. T is 5.43. So t is 5.43. But what was the question? The question was, in what year? So these are years since 2010. That is the year 2015. So in the year 2015, the population hits 120, okay? Okay, that's an example of setting up an equation with exponential growth. And then we move into half-life problems. So half-life problems are just a special case of exponential decay. So the formula we have, you'll see it written at the top of the first page, a 0.05 x over h. So y is equal to so in Chernobyl, that was 1986, there was an isotope cesium-137, has a half-life of 50 years. It's estimated 2.5 megacuries of cesium-137 were initially dispersed. Write an equation R of t that expresses the remaining radiation. So the radiation that remains in Chernobyl is, okay, I need to look for what was my initial value. My initial value was 2.5 megacuries, and then this is half-life, so it's 0.5, and then this is going to be t because that's my variable, divided by what is the half-life. The half-life is 50 years. So that is my equation. R represents the radiation remaining, and always give a unit, and that is in megacuries. You don't have to know what a megacurie is, but this formula gives radiation remaining in megacuries. T represents the time since, when did this model start? In 1986. Okay. Now I could have asked you to go further with this. I could have asked you, what's the radiation in, currently today, and you could plug that in. Or I could say, when will the radiation reach, 1 megacurie? So those are certain things. If you wanted to go further with this problem, for the test, this was last year's test, so I just wanted to see if you could write the problem and set it up. I did not ask questions because if you set it up wrong, you get wrong answers. So I sort of broke this test down into different skills. Now I give you a model here. In general, a new car will lose 16% of its value annually. The value of a new car costing $50K can be modeled by this equation. V of t is 50,000, 1 minus 0.16 t, where t is the age of the car in years. What's the value of a car in 6 years? So 6 years from now, t will be 6. So I need to figure out what is 50,000, 1 minus 0.16 to the 6. So just go to the calculator. 50,000 times 1 minus 0.16, and then raise that to the 6th power. 17,564.90. So 17,564.90. That is the value of this car in 6 years. In how many years? That's solving for time. In how many years would the value of the car be 5,000? So I'm looking at, when does 5,000 equal 50,000, 1 minus 0.16 to the t. Solving for t, I would do that on my calculator. So menu 3, 1. So 5,000 equal 50,000 times 1 minus 0.16, and all of that is raised to the t power, and I need to solve this for t. And when I do that, 13.2. So 13.2 years to reach the value of 5K. The next one looks like a half-life model again. The cafe and a grande latte remaining in your system after consuming coffee is modeled by the equation C of t is 150 times 0.5 to the t over 4/8, where C is the amount of caffeine in milligrams, t hours after consumption of the coffee. How much caffeine is in the grand latte? That's the initial value. So initially you have 150 milligrams of caffeine in the coffee. What is the half-life of caffeine? Well, you look at our formula for half-life was this. So H was the half-life. So this half-life is 48, and the unit is hours in this case. So 48 hours is the half-life. So I would expect half of the caffeine to be gone after 48 hours. How much caffeine is present after 36 hours? So that just substitute t equal 36. So that is going to be C is equal to 150 times 0.5, and this is going to be to the 36 over 48 power. And just go straight to my calculator with all of that. So 150 times 0.5 raised to the, 36 divided by 48, and 89.19. So there are 89.19 milligrams after 36 hours. How many days until the caffeine is 25 milligrams? So here, days is bold, okay? I got to pay attention to that because my formula is in hours. So I'm going to have to do something when I get an answer here. So how many, first of all, figure out 25 milligrams. So when will there be 25 milligrams? So I started with 150, 0.5 to the t over 48. Let's solve this for t. We'll do that with our TI Inspire. So menu 3, 1. So when is, 25. So 25 equals 150 times 0.5 raised to the t over 48 power, and solve that, so comma t. Okay, so solve this for t. T is 124,078. So T equal 124,078. Those are hours. What was the question? How many days? Okay, I need to convert hours to days. So 124.0, did I write that down right? 078, yes. 0.078 hours. I know that there are 24 hours in one day. So when I multiply this out, my hours will cancel. So I just need to figure out what is 124,078 divided by 24. So 124,078 divided by 24 is 5.17. So that is about 5.17 days. And that is it. Okay, so fairly short, just two concepts: exponential growth, exponential decay. Make sure you are clear on the decay rate versus decay factor, the growth rate versus growth factor, and then half-life problems, where everything is 0.5 raised to a power.